All right, so as promised, here's our chemistry lecture for Tuesday. I'm recording this video for you so that when I'm out on Tuesday, we don't have to miss really important information for the class. So you guys should have your spiral notebooks out right now. You should have the page titled Chemistry Notes, Elements and Bonds. If you don't have your spiral notebook out, get it out because this is going to be included in our spiral check on Friday. Okay, so, oh yeah, lastly, before we get started, normally in class I would pause and I would give you guys time to write, but since this is a video, you guys can pause it yourself. So I'm gonna go through this a little bit faster than I would in class. Just pause the video if you need to, write stuff down from the slide. Okay, so here we go. Okay, so chemistry of life. So these are just like some basic definitions we need to know. So all matter is composed of tiny particles called atoms. If you don't remember from previous classes, matter is anything that has mass and takes up space. So, I mean, it's not everything in our universe, but it's pretty much everything that we can see and feel and interact with, okay? So it's all made up of atoms. So there are 109 types of atoms, so different types of atoms. A substance made up of one kind of atom is called an element, and an atom is the smallest part of an element that has the properties of that element. So if you have like 5 atoms of carbon and you've got 1 atom of carbon, they're going to behave the same way. Okay, so 1 atom of carbon will behave the same as 5 atoms of carbon. Okay, so in this class, we're going to see most of the time when we talk about elements, we're going to be talking about these 6 elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The reason why we talk about these most often is because these elements make up 99% of organic matter. And organic just means living. Okay, so living things are primarily made up of these 6 elements. Okay, so we talked about atoms, we talked about elements, we talked about the elements most common in living things. So our next thing is molecules and compounds. So anytime 2 or more atoms are going to bond together, they form a molecule. A little differently, a compound is a substance made of 2 or more different elements or different types of atoms. So for example, you could have a molecule of oxygen, which is just 2 oxygens bonded together. We would say that's a molecule of oxygen and not a compound because it's the same element, same type of atom. However, we can have carbon dioxide, which is a carbon and 2 oxygens. We would call that a molecule because it's when 2 or more atoms bond, but we'd also call it a compound because we've got a carbon atom and we've got 2 oxygens. So we've got 2 different types of elements or 2 different types of atoms. If we were in class, I would give you guys time to talk about this and I would say, how is it that 2 atoms can make a molecule and not a compound? We kind of just went over that example. If you have a molecule that just has the same elements in it, like oxygen bonded together, or 2 hydrogens bonded together, or 2 nitrogens, or 2, I don't know if I said hydrogen, but 2 hydrogens bonded together, those things would be molecules. They would not be compounds because compounds have 2 different types of atoms. Okay, so why would elements want to bond in the first place? Why wouldn't they just want to be separate and, contained in their own types of atoms? Well, this kind of requires us to have a little bit of review from our, I think it's 8th grade science class. If you remember, the structure of an atom is that you've got protons and neutrons in the nucleus, and you've got electrons outside the nucleus floating around. On this figure, it's shown as like electron rings, or sometimes they're expressed differently, but there's shells where these electrons kind of float around. So there's this thing called the rule of 8. So every single atom, every single type of atom, they always want to have 8 electrons in this outer shell. They always want to have 8. These electrons on the outer shell are called valence electrons because this is called the valence shell. The only exception to the rule of 8 is hydrogen, and hydrogen's rule is more like a rule of 2. So basically, if you have an atom, right, that doesn't have 8, or if it's hydrogen and it doesn't have 2, it desperately wants that. It desperately wants to complete its outer ring. That's going to drive the atom to bond with another one so that it can get access to 8 electrons in its outer shell. So there's 2 ways that it can do that. There's 2 ways that atoms can bond together in order to get 8 valence electrons, or in the case of hydrogen, 2. So the first type is ionic bonding. This is when atoms either gain or lose electrons. So this is a trade or an exchange of electrons. And in doing that, they become electrically positive or negative. If you remember again from your 8th grade science class, electrons have a negative charge. So if an element, which is normally neutral or has no charge, gives away one of its electrons, it's like it's giving away negative charge. And in the process of giving away negative charge, the element will become positive. Same if you receive an electron. If you are neutral and receive an electron, or you receive negative charge, then you are going to become more negative. That's what this is showing here. So it says Na+, this is sodium, and it's got a positive charge because it gave away one of its electrons. So this is a chloride ion, and it's negatively charged because it received an electron from the sodium. Because sodium gave away an electron and became positive, and chloride received an electron and became negative, now you've got a situation where you've got a positive and you've got a negative, and so they're going to be drawn to each other. Both are now happy because they've made their 8 rule. So now in this example, sodium, now the outer shell is empty. So its new outer shell is going to be the one in the middle, and that has 8. And chloride is happy because it has 8 in its outer shell. Okay. The second way that atoms can complete their outer shell is through covalent bonding. And so covalent bonding is when atoms share electrons. And when they share electrons, it's like they get access to electrons from other atoms, and therefore they have a complete set in their valence shell. So water is a good example of this. On the left, it shows the elements or the atoms before they're bonded together. And on the right, it shows after. So if you notice before, you've got 2 hydrogens here, and both the hydrogens only have 1 electron. Okay, so they're not happy, they want 2. Both of these want 2. The oxygen has 1, 2, 3, 4, 5, 6. Okay, so oxygen has 6 on its outer shell, so it's not happy either. Well, if the hydrogen shares its electron here, and the other hydrogen shares its electron here, now it's perfect for all atoms involved. This hydrogen now has 2. It wants 2. Same with this hydrogen. And now oxygen has 8 electrons in its outer shell. So by sharing, it's like they get access to the other electrons and they're happy. This is a chart that kind of just summarizes the difference between the ionic and covalent bonds. This is probably something that would be good to write down. So in the ionic bonds over here on the left, atoms gain or lose electrons. This is a very strong bond strength because of that magnetic element, that magnetic like aspect of the bonding is strong. And then we will talk about this last part probably next week, but ionic bonds break in water, so water can dissolve an ionic bond well. Covalent bonds are over here on the right. In a covalent bond, atoms share electrons. We say it's a medium bond strength. And then with covalent bonds, we'll get to this later, but there can form single, double, and triple bonds. the kind of common ground between these two types of bonds is that it's an attraction between two or more atoms. And then really importantly, the reason why they're attracted to each other is because they're trying to complete themselves. They want to fulfill that rule of 8, or if it's hydrogen, they want to fulfill that rule of 2. Okay, and this is just a little video. We are not doing this part. We're not answering any questions on a half sheet of paper, so just ignore that. I put the link in there for you if you want to watch it. This is just like a interesting video about atoms. It's actually really old. I think the year it was made was like 1952. So super old, but it's kind of interesting and it's a nice supplement to this lesson. So if you would like to watch that, go for it. So keep these notes that you just took in your spiral. They will be included in the spiral check, and the content of these notes will be on your quiz on Friday and your unit test 2 weeks from now. If you have any questions about this, please make sure you talk to me during class and make an appointment with me so that we can go over what you don't understand. Personally, I think chemistry is confusing, so if you're feeling confused, maybe watch the video again or come talk to me. All right, thank you for watching. See you guys in class.